Hi guys, I hope you are doing well in your homework problems with chapter 2. So, in chapter 2, at the end of your lecture slides, there are some concepts related to vectors. So, I wanted to make clear on vectors, how to add vectors, and I'm helping you in question number 15 and question number 16 that are related to vectors, okay? So that it will be easier for you to deal with this kinds of problem, okay? So we can add vectors by using vector method that are graphical method that we say triangle method and a parallelogram rule or parallelogram method. Look at here, parallelogram rule. So what is parallelogram rule first? Before talking about parallelogram rule, now what is the parallelogram? Let's understand that. I hope you are familiar with parallelogram from your high school. Let me draw a parallelogram right here. If you have a structure, geometric structure like this, that is two opposite lines are equal and parallel to each other. That is the parallelogram. Okay, so this line is parallel to this line, parallel and equal to this line, and this line is parallel to this line, and this line also parallel and equal to this line. Okay, so opposite lines, opposite sides, we can say, not only line, opposite sides in a parallelogram are equal and parallel to each other. That's why this is parallelogram. So opposite angles are also equal to each other, right? Opposite angles means this angle is opposite angle of this one, and this angle is opposite angle of this one. So in this question, look at here. Let me clear this one and go to the equation. Using the graphical method, you are using graphical method, not a numerical method. Use the parallelogram rule, that means not a triangle rule. Add the vectors shown in figure A and the vectors shown in figure B. Okay, so first thing is, as I draw my parallelogram before, you have to complete parallelogram. You can probably put dashed lines. I'm just using solid lines. I don't have option, I think, to draw dashed lines. Okay, anyway. So first thing is you have to complete parallelogram like this. So make sure when drawing, I think this is almost a parallelogram, but when you draw actual parallelogram, make sure this line is parallel to this one. Okay, so the distance between them at each point should be same, right? Put 2 points at equal distance from here, and then they will be equal. Okay, so you completed parallelogram now. So that's what this question is asking. Now addition means, add means, now you have to find the sum of these two vectors. That's what addition is, right? So let me tell you what is the resultant or sum of these two vectors, vector this vector and this vector, right? So after completing this parallelogram, draw a line from this corner to this corner and put a little vector here, vector sign here. Let me come down. So I mean arrowhead here, right? Arrowhead. This is the resultant, that is sum of vector. Suppose say this is vector m and this is vector en. So this r, which we call diagonal, right? This line is said to be diagonal. So this diagonal is sum of m and n. So you can write down m plus n is r, right? A resultant. Resultant means sum of two things or more than two. Okay, so measure after drawing, you can do same thing for this one. The direction is a little bit different, so geometric figure will be different, but method is exactly same like this one. Okay, so I don't have to do it again here, so you can just repeat the same process again. So measure both resultant and show these values in the diagram. Okay, measure both resultants. Resultants means resultant this one, and you also have resultant here. After completing this parallelogram, you have resultant here. This is also resultant, right? Measure and show these values in the diagram in centimeter. You can use the meter scale or ruler to measure this length centimeter. You can exactly measure, and this length in centimeter. You just can use ruler, right? You have a ruler like this, put ruler here. This is a ruler here, right? Here are scales, and then you will be able to measure these. Which resultant is larger? This one is larger or this one is larger? You will see once you measure it, then it is quite simple, right? After drawing, you can easily measure by using ruler. Okay, the resultant in figure A or resultant in figure B, which one is larger? Then write down if resultant in A is greater, write down resultant in figure A is greater than resultant in figure B. I hope you get this question. So let me go to another question. There is a one more question I wanted to help you. I wanted to do for you. Look at question number 16. This is also vector related. Okay, so vectors are those physical quantities that requires magnitude as well as direction. So you cannot define vectors like a magnitude. That type of quantities are said to be scalar. For example, 1 kilogram. It is not a vector. It is a scalar because when we say 1 kilogram, nobody asks you question which direction. It doesn't matter which direction is, right? So direction is not required to define scalars. That is a scalar. Vector means like velocity. If I say I'm moving, I'm driving with velocity 30 miles per hour, then you may ask, which direction? Are you going to north towards Kentucky, or you're going to south towards Huntsville? Which is your direction? That is the vector. That means vector are those physical quantities that requires magnitude as well as direction. Okay, I hope you are clear. This question says consider a pair of forces, one having a magnitude 32 newtons and the other of magnitude 17 newtons. What is the strongest possible net force for these two forces? Okay, one question. When does this happen? Second question. What is the weakest possible net force? When does this happen? Okay, these are four questions you have to answer. Now, let me draw a vector. This is a vector, and so we have to draw here. Suppose this is a 32 Newton force. So make it larger, right? Make it larger. 32 Newton. And another vector is 17 Newton. Make it smaller. Okay. Make it smaller. This is 17 Newton. Okay. So if you add 32 Newton and 17 Newton, then it will come 49. So 49 is the maximum or strongest possible net force because of these two vectors, two forces. Force is a vector. Okay. So when did it happen? When could it happen? So it could happen only when they are oriented in same direction. Here is the answer. Okay, I have written answer here. When they are in same direction. This is the answer of first two questions. What is the net strongest possible force? This question. And when does it happen? When they are oriented in the same direction. This direction or both are oriented in upward or both oriented downwards or other direction. Both should be in same direction. That is the condition, right? Second question is when is the weakest possible net force? When they are facing opposite direction. Wherever they are facing, they should be opposite. Okay. So maybe they are facing this way and this way, maybe facing this way and this way. Okay. So in that way, they will have the weakest possible force. So in that case, you have to subtract, right? Look at here. If you subtract 17 from 32, you will get 15, right? Then when they are anti-parallel, that means they are facing opposite direction. Anti-parallel means opposite direction, okay? So you can say same direction and opposite direction, okay? I hope you are getting these vector concepts. If you have any more question, you can email me and I will help you, okay? So, bye-bye.